So before we talked about certain data types, we mentioned strings before, but we particularly went into a lot of detail when we were talking about integers and floats. But now we're going to talk about strings and also characters. Characters are not a part of Python, unfortunately, but it's also something good to know, especially if you want to delve more into computer science using different programming languages. So let's go ahead and get started. So like I said before, we did deal with strings before. So for example, when we did print hello world, there are two different ways that we could have written this. Notice that the first time around we used double quotation marks, but we also could have used single quotation marks. Single quotes, double quotes, they both work. We could have also stored them into a variable. So instead of just straight up printing hello world, we had different options. You can see here we use single quotation marks to store our string, and the string is stored in this variable sq text. But we also had another option where we stored a string in double quotation marks in a different variable text. Regardless, all of these three blocks of code, they all do the same thing. Or I guess technically 4 blocks of code if you consider that this one right here is different from this one right here. They both print out, or they all print out hello world. The way that we do it is a little bit different for each time around. So when we just talk about the different nodes in Python, the different observations, we can see that strings can be surrounded by either single quotation marks or double quotation marks. And strings can also be stored as a value in a variable. They don't have to be standalone values, just like how we see in this one right here and this one right here. Stored in variables, do what you will with it. Also, we talked about how to convert something into a string. For example, we have a number 1 right here. We have the number 1, but if we want to convert it into a string, instead of using it as an integer value, we could just use our function str. Whatever we put inside of those parentheses will be converted into a string. So rather than it being printed as a number, it'll be printed as a string. So this should all be reviewed. We've covered this in previous weeks of AP Computer Science Principles. And now we're gonna get into something new, characters. So what are characters? It is a fundamental data type used to store a single character. So one single character, not multiple characters, so that makes up text, one single standalone character. Now, character can be different kinds of text. So let's just go ahead and break it down a little bit further. But first off, you're going to hear me call it a char. So not car, but char. You're going to hear me say a char variable just because it's a little bit shorter. If you are going to take, if you learn C++, or if you learn Java, you might hear, actually mostly C++, you're going to hear this word thrown around a lot. But in Python, this is pretty much non-existent. But I would still like for you guys, especially for those of you who are planning to take the AP test, to know what this is, even though you might not need it for Python. So here's some examples of chars. So we have capital A. This is a single character. Note that this is a one singular character. We have lowercase a. This is another different kind of character, a single char. And then we have the number 0. Once again, this is a single character. Even though this is a number, now that we have the quotation marks around it, this is not a numerical value, rather this is a text value. And we also have this pound sign, hashtag, whatever you guys call it. They're all the same thing. It's that symbol right there. With the quotation marks around it, that is a text value. So a char or a character, whichever one you decide to call it, is one single character. And then I just want to write this note. Python does not support characters, but you'll see this in other languages. So once again, characters do not exist in Python. We only have strings in Python, but you're going to be hearing me throw this terminology around. So I just want to clarify it that way when we go ahead and talk about it. And when we get closer to the AP test, you guys will find it familiar. So let's talk about characters versus strings, what differentiates the two. So a character, remember, is a single character of text, whereas a string is any kind of text. A string could be one single character. It could be a combination of multiple characters, or it could be no character at all. It just depends on what your value is. So examples of strings, we have the same values that I gave for the previous slide, lowercase a by itself, capital A by itself, 0 by itself, and the number sign by itself. A string could also be these things. So I guess maybe I should clarify a string. Yeah, actually a string could be lowercase a, capital A, 0. It could be a number sign. It could also be an empty string, which is pretty much a string. So empty quotation marks with nothing inside of it. But because we have those quotation marks, we know that it is a string. It could be a combination of characters put together. It could surpass just being a singular string. It could be a combination. And finally, we could also have phrases, including having spaces in there. A space is still a character. Thus, when you put it inside of quotation marks, that is a string. So also we could have a blank character like this. There's nothing in here. That would be a character as well, all by itself, a space. So let me actually this right here, this is just an empty string or empty character, or just this empty space, white space, if you will. So also something that I want to clarify, in Python, you can use single quotation or double quotation marks or single quotation marks, oops. But in other languages, you use only double quotation marks. Whereas for characters, you would have to use single quotation marks just to differentiate. So it just depends on what language you are using. But for specifically in Python, they're interchangeable because there's no such thing as a character in Python. But so for string, you just have the flexibility to use whichever one you want. We're gonna be doing a whole bunch of examples, so this is just like really confusing right now. Don't worry too much. It'll become a little bit clearer when we go through the examples, so don't worry too much yet. And now I want to introduce what we call the Ascii table. So Ascii, we are just going to introduce it today, and then in 2021, that's when we are going to go over a little bit more about the Ascii table. So for now, I want you to focus only on these columns right here that I'm highlighting. So the columns that say decimal, so DEC, focus on that column, and also focus on the column that says char, char. So focus only on these columns. Ignore the other columns that say like HX, octal, and HTML. Just ignore those for now. Those aren't necessary. Like I said before, we're gonna go over it in the second half of the school year. So Ascii table. So Ascii stands for American Standard Code for Information Interchange. So you don't need to know that name. You could just know it as Ascii. But this provides a relationship between a number. It provides a numerical code for each specific character. So if I say, for example, what would the numerical code for the letter capital A be? Well, if you look at capital A, which is right here, we can see that the numerical code that is provided for it is 65. What about lowercase a? What is a numerical code for lowercase a? So here's lowercase a, And yes, the numerical code provided for it would be 97. So the ASCII table, like I said, it just gives a numerical code, a specific number for a specific character. Note that there is another table, there is another code called Unicode. So like this Unicode would have beyond just American characters like the English alphabet. It has Greek letters, it has mathematical symbols. So Unicode is a more extensive table that you could also find, but I believe for the AP test, you're only being tested on ASCII and like certain parts of ASCII. So you don't have to worry about Unicode. But in case you're wondering like where did all of the other characters go? Oops. They are all found in the Unicode table instead of the ASCII table. But the reason why I want to introduce the ASCII table, even though we're not going to go into a lot of detail about it, is because of the implications of the ASCII table. So I'm going to be switching between this slide and the next slide quite a bit. So if you look at, oh, what's going on? So if you look at the next slide then, we want to test a couple of things. So I want to say, like, pick your brains, have you guys answer these questions, and we'll also go over these. We'll also test this out through code so you could see it firsthand. So would the character or would the string capital A be equal to lowercase a? What do you guys think? Very good. It's gonna be a no. So let's think about it in terms of just the ASCII table. When we were comparing in the previous slide, the numerical representation for capital A is 65, whereas the numerical representation for lowercase a is 97. Despite both of these being the same letter, they're both A, they're not the same code. So let's go ahead and actually try this out. Let's code this out and see, are capital A and lowercase a the same thing in the eyes of Python? So give me 1 second to, oh no. 1 second. I was kind of hoping to share. All right, can everyone see this okay? I have the chat closed, so I have to reopen that. Can everyone see this okay? The screen? Okay, perfect. So we're just gonna go ahead and test to see, are uppercase A and lowercase a exactly the same or not? So let's go ahead and test this. So we'll have our first string be equal to uppercase A, or uppercase A, whereas the second string, so string 2, be equal to lowercase a. So if indeed string 1 is the same thing as string 2, we can print these are the same. However, if they are not the same, we can print out that these are different. So if our prediction is correct, capital A and lowercase a are 2 different characters, then we should see that these are different will print out. Let's go ahead and test. And we can see, indeed, these are different has printed out. So despite these both being A's, the letter A, these two are 2 different characters. We've seen this firsthand in our code, but furthermore, we can see it's apparent in the Ascii table. Now, here is a little bit more of a trickier one as soon as I open the PowerPoint again. Which one comes first alphabetically then? Capital A or lowercase a? I'm going to switch over to the Ascii table. Which one would come first alphabetically? Capital A or lowercase a? Capital A, very good, capital A. So the reason why, hopefully the reason why a lot of you guys are saying this is because of what we have right here in our code. Capital A has a smaller code associated with it. We have 65 as opposed to 97 for lowercase a. So when we compare which one would come first alphabetically, it would be the capital A. The best way to do this is actually just to use a less than or greater than sign. So let me switch back over to the code. I don't think I share the right thing. Can everyone see both windows? All right. So rather than instead which one, if they're the same or not, we want to see which one comes first, I guess. Which one comes first alphabetically. So I'm going to try to copy and paste this part. So rather than checking if they are equal to each other, I want to see which one would come first. So which one has a smaller value associated pretty much, because a smaller value insinuates that it comes first alphabetically, it comes first in the order. So let's go ahead and compare which string 1 or string 2 comes first in terms of the order that we want or the order that we have. So if string 1 is less than string 2, then we want to print string 1 comes first. Otherwise, we want to print that string 2 comes first. Actually, let's make this a little bit more accurate. So in the case string 1 is not less than string 2, we have two different paths that we can go from there. Are they the same? Or is string 2 big, or is string 1 bigger than the other? So and it's not just string 1 is less than string 2 and then string like we have a different thing going on. We have three cases. String 1 is less than string 2, string 1 is equal to string 2, and string 1 is greater than string 2. So I'm just going to write out all three cases. So if string 1 is less than string 2, we will say string 1 comes first. Otherwise, if string 1 is equals to string 2, we want to print that these are the same. Otherwise, we would say that string 2 would come first in our order. So once again, we have three cases instead of just the two that I was intending to have. Let's go ahead and save this and run it here. And we can see that capital A comes first. If I change it to a lowercase a so that both of them are lowercase, we can see that these are the same. If I change this one right here to capital A, we can see that capital A comes first this time. If I change it to both of them are capital A, you can see that these are the same. So we've just written out flawless code that will help us figure out the ordering between two different characters. Any questions so far? Okay, then I'm going to go back to the PowerPoint and we're just going to continue where we left off. 1 second. So which one comes first, capital A or lowercase a? We are going to say capital A comes first. So which one comes first here? Lowercase a or uppercase B? What do you guys think? Capital B, very good. So hopefully you guys are saying that because of our lovely Ascii table right here, where we have, what was it again? It was lowercase a, capital B, yes. So capital B has this code 66 associated with it. So even though B comes after A in our actual alphabet, the code that is associated with it, so for in the terms of lowercase a, it is 97, and in terms of capital B, it's 66. Capital B will come first in that order. I know it's a little bit weird, but this is just how the Ascii table is written out, and that's how this is going to work out in terms of which one is bigger and which one is smaller. So let's go ahead and just go ahead. We're going to verify this before I write it down in this section right here. Let me share the other screen. Oops, hold on a second. I just have to reopen. Accidentally closed it. Okay. Let me share this again. I'm going to close this. All right, so we had capital A and capital A. Now we are going to do A and capital B this time. And then upon saving it and running it, you can see that B will come first. So those of you who said that B would come first are absolutely correct. And I just lost my Apple Pencil. There it is. So going back to the PowerPoint, actually before we go back to the PowerPoint, if I change this to a Z, what do you guys think? Which one do you think will come first? A, lowercase a, or capital Z? Right. We have capital Z comes first, which in a way seems really bizarre because it goes against everything you guys know about the English alphabet. But remember, this is based off of the Ascii table, the Ascii code. So numerically, it makes sense, unfortunately. So in terms of which one comes first, lowercase a or capital B, we established that capital B will come first. Now, does one come first or does capital A come first alphabetically? Yes, one will come first. If you take a look right here, there's that one. One has a code of 49. I don't know why the code for one is not 1. I don't know why they just made it 49, but the code for 1 is 49, which is smaller than, what was it? We're comparing it with A? Yes, we're comparing it with capital A. So let's go ahead, and before we go ahead and do this, let's verify it with our code. All right, so this time we're going to compare the number 1 as a string. So make sure you keep the quotations around it. If you don't put the quotations around it, it'll think that you're talking about 1 as a number. So you have to keep the quotation marks around it. And then also this capital A. So when we run it, we can see that 1 comes first alphabetically, or really in terms of our Ascii table. So going back to what we have before, in terms of what comes first, 1 or A, hopefully you guys all said that it was 1, or you guys all thought that it was 1 just by looking at our Ascii table and not even having to use Python. So if we were to order these alphabetically, capital H, hello, lowercase h, hello, and then all capitalized HELLO versus H3LLO, how would you order this? What would be the very first thing? Good, the very first thing should be hello. The reason why is because this is capital, this is capital, this is capital. Remember, capital letters have priority, or are at the beginning, or not the beginning, capital letters precede lowercase letters. So we have this hello, all capital letters, versus this hello, which only has 1 capital letter at the very beginning, versus these 2 hellos, whose first letter is lowercase. So you already know it's going to be a showdown between the 2 capital H hellos, but because the second letter for this one over here has a capital E versus a lowercase e for the other hello, we know that this one will come first, which also means what would come second? Very good. Capital H, lowercase everything else. This will be second because of that same reasoning. We have this capital H right here, so we know this is going to hold priority over the second, not priority, it's going to precede the other 2 hellos that are not ordered yet. But it's not enough to be ordered before this one because of the lowercase e. What would be the third thing in our list? Very good. This one right here would be third in our list, H, and then 3, LLO. And the reason why we know that is because when we compare our first letters, we have the 2 H's, they're the same. But when we look at the second letters, we see that the 3 versus the E, 3 comes before E in the Ascii table. We can see that here, even though it's like a lowercase letter, the number 3 will precede a lowercase e. So H3LLO exclamation mark will be third in our list. And last, we have our regular hello. So this will be the order of our strings. So hopefully just by just having looked at the Ascii table, you can see a couple of characteristics of it, how things are ordered, and how you can't just directly assume that despite this one, and this one, those first 3 all have the same letters. They're all HELLO with an exclamation mark. They were ordered differently just because of the casing, which one's capital and which one is lowercase. So you can't just go in and compare strings based off of the characters alone. You have to make sure that the casings match or the casings match as you intend it to. There are other kinds of special characters that we haven't discussed, but we will now. All the characters that we have discussed or seen so far were like uppercase, lowercase letters, numbers, or just special symbols like exclamation marks or like a number sign, period, commas. Those are the ones that we've seen, but there are different ones out there, and these are called escape characters. So before I talk about what an escape character is, let me give you an instance in which you would need one. So I'm going to comment all of this stuff out. Let's say you want to print what did I say we need to print? You need an escape character for these situations. So we want to print exactly that. You need an escape character in quotations for these situations. So if I try to print that, print, you need an escape character for these situations. So we have an issue. Oops. Oops, it's supposed to be like this. This quotation mark right here is supposed to signify the beginning of your string. This quotation mark here is supposed to signify the end of your string. The quotations in the middle, this one and this one, are supposed to match this and this. But the way Python is interpreting it at the moment is that instead of these two quotation marks going together, it thinks that you're trying to match these two together and then these two together. You can see that because of what is in yellow. You need an is yellow. So it thinks that the two quotation marks or the pair of quotation marks that are immediately next to each other are paired together. And then after escape character, it thinks that the quotation marks that follow that, that's surrounding for these situations, is another set. So if I try to run this, I would get an error because it does not make any sense to Python at the moment. So this is where our escape character comes in. But before I show you more about the escape character, let me just show you what happens if we try to run this. So if I save it and then I run it, I get an error because it has no idea what you're talking about. It just says invalid syntax because it doesn't understand. So an escape character is something that is not really in the form of one character, but it is a character that allows you to break the common the norms of strings. You will always see this slash in front of an escape character. Notice that the quotation marks are no longer yellow, but rather they are purple. That's because a slash with a certain character after it indicates an escape character. This is what you want to use instead of just regular quotation marks. So you need an and then slash quotation mark. This will allow Python to understand that this is not a quotation mark to close a string, rather it is a quotation mark that should be included in the string. So if I save this and I run it this time around, you can see it prints you need an, and then we can see the quotation marks. That slash isn't there. It's because Python has an understanding that this is an escape character. So it says you will print an escape character for these situations. There's a whole bunch of different kinds of escape characters. Let me show them to you and then we could test them out. There's a lot, but I'm probably only going to show you like 5. So, so we just did that example. So you need escape characters. Some common ones are listed below, and then we have these. So we have a /T. This is a tab. So normally when you indent, you press tab. So that /T will literally provide an indentation for you within your string. If you have /N, this means a new line. We've, I don't know if we've used this before or not, but if you have // this means just one singular slash. The reason why you need this is because normally if you just have a slash, Python will think that you're trying to use an escape character. So if you just have a slash, it's gonna wonder what is missing, like what is supposed to go there. So you have to have a // if you want to use one slash. So need to use this, otherwise Python will ask for an additional character. And then we saw an example of this already, the slash quotation mark, this slash quotation mark. But this also applies for single quotation marks. So these I would say are the most common ones that you would use in Python and also for C++ and also Java. But if anything, the one that I use the most is this one and this one over here. I don't really use these as much because I use a different formatting thing, which we can talk about later. But let's go ahead and try some examples. That way you can see firsthand how you could use the /T, /N, pretty much all of these escape characters. Hold on a second. My computer is having issues right now. Okay. Can everyone see the screen? I was having issues a little bit earlier, but can everyone see both of the windows? Okay. So we used our quotation mark escape character. Let's try a new line escape character. So let's say instead of me wanting to print out 2 separate lines using 2 different print statements, I want to try doing it in one print statement. So I want to try to print exactly in this format. Print hello on the first line and then world on the second line. That's exactly how I want it to print. Hello and then world without using print more than once. So if you want to do that, you want to print hello, then use your escape character of new line, which is the \n and then world. So you could already see that that /n is purple. That's because it understands, the Python understands that this is an escape character. It's not just something that's going to be printed out in the string. When it sees that slash, it knows escape character, and then it'll look for the immediate text character after it to see what kind of escape character you want to use. So if I save this and print it, we can see hello world printing out on 2 separate lines as opposed to 1 line because of this lovely thing over here. So it's a helpful tool if you do want to print on separate lines, but you don't want to use print multiple times. You could also use the indentation. So let's say you want to tab things over, then in that case, you can use the T. So let's say I want to print using a tab, like a space over, and then hello, and then a space over again, and that will be world. So tab, hello, tab, world. So if that's the case, we can just use inside of quotation marks back that /T for tab, and then hello, and then another /T, and then world. So tab, hello, tab, world. That's exactly what's going to print out. So if I go ahead and run this, oops, you can see that tab, hello, and then a tab, and then the world. So prints out as exactly as expected, pretty much. Let's see, what can we use? What can we print out? Let's say I want to print out this space right here. So that what I want to print out for this one, I want to print out a face that looks like this. If I just try to do print and then the colon and then a backslash, notice this purple line that follows right after it because it's expecting another character. It's expecting something for an escape character. But we just want a slash. We just want this slash right here. So in order to tell Python, hey, this is what I need, we're gonna need to include 2 slashes. But Python will understand that because that this is not an escape character that's supposed to be like a different letter, this is going to be just that 1 slash that we wanted. And we have this that prints out now, despite having 2 slashes in the original print statement. So these are all different kinds of escape characters that you can use, just depending on however you want to format a string that prints. Any questions so far? Okay, let's go ahead and move on to the next slide then. So how combining characters or strings. So you could think of this as arithmetic or almost like adding things together. When we, instead of saying that we add things together, we use this word concatenate. Concatenate. Concatenate just means to link or to chain together. So let's take a look at this example right over here and see how we are concatenating strings. So I have my string 1, which is hello, and string 2, which is world. So if I do string 1 plus string 2, that means I'm concatenating, literally linking or chaining these 2 strings together in that same exact order. So string 1, which is hello, string 2 is world. So what would print out is hello world, no spaces. There are no spaces in this at all because there's no spaces that were included in the strings. When you concatenate, you just put one after another. Nothing is being included unless otherwise specified. In this case, nothing was specified, so we just put hello and then world right after. When we move on to the second example, just to take a look at how this one looks, we see hello and then world. Same string 1 and string 2, but if we look at line 3, there's some things that are different in there. We're still concatenating, but we're concatenating multiple things, more than just two things. So we have string 1 first, plus a space, an empty white space, which is still a space. So that is hello with a space there. So we're just going to leave it as an empty space, as if someone just typed it in, like with a space bar. And then we have the next thing, string 2, which is world. So we have hello space world plus an exclamation mark. So this is what's going to print in string 3. So there is a clear difference between the first example and the second example. In the first example, it was just string 1 plus string 2. Therefore, when you print string 3, which is a concatenation of string 1 and string 2, it's just hello world bunched together as one word. Whereas for the second example, when we did the concatenation for string 3, we did string 1, which is hello, plus a space. So you include a space, plus string 2, which is world, and then an exclamation mark at the very end. So we have hello space world exclamation mark, and that's exactly what's going to be presented to you through the concatenation. When we take a look at example number 3, this one right here, something very similar to example 1 and 2 is going on. It's just that instead of strings, we're dealing with characters pretty much. So I have a single character, H is high, or for H, and then a single character for I. So if I concatenate these in the exact order being presented, I have H plus, this is H, and then plus I. So I have high being printed out. Despite the fact that these are both individual characters, once you concatenate two characters, you have a string because it is multiple characters being put together as one value. Multiple characters means string immediately. So when adding two strings, you get a string. And we saw that here. We saw that in both example 1 and example 2. When adding two characters, you still get a string. And we saw that in the third example where when you combine two characters, because your output is something with multiple characters, that is a string, which means when you're adding a string and a character, that will still be a string. Because when you do string and a character, that just means you have still multiple characters in as one value. Definition of a string. So you get a string. And also, when you switch the two, when you do a character, when you add a character and a string, regardless, you will still get a string as your output. We did a couple examples of these at the very beginning of this class. I didn't explain exactly why it works, but this is exactly what is going on. You're just literally concatenating. You're doing one right after another, combine it as one new value. We still have time, so I am going to go over the anatomy of strings. So when we talk about the anatomy of strings, how strings are labeled, how characters of a string are labeled, I guess, we can just say that they are stored in a very particular order where each character is associated with an index. So H, H is stored in the 0th position. And that's a very important distinction to make. In Python, in Java, in C++, in Ruby, in pretty much every single language, C, it starts at 0. But for some reason, for the AP test, College Board will use the number 1. They say that the indices start at 1. So it really makes me mad to see that. But if you're interested in coding, like when you go to college or for the rest of high school, it starts at 0. But for the purpose of this AP test, it starts at 1. So for now, we'll start with 0, but when we start practicing for the AP test, you're going to make the transition for it to start at 1. So for 2020, the rest of this year, it starts at 0. Later on, 2021, we're going to start practicing where it starts with 1. So, it just makes me mad when I think about this. But it starts at 0, so that means things are a little bit offset. When I say something is the 0th character, I really mean what is in the first position. So when I say what is the first character, I mean what is in the second position. So when I say what is the 0th character, literally the first character when you look at the string. Everything starts with 0, not 1. So it might be a little bit confusing, but whenever I ask about a certain character number, you have to offset it by 1 because I'm not literally talking about the first characters, or I'm not talking about like literally what it is. So if I say 0th character, this is really what is the first character. If I say what is the first character, I'm asking what the second character really is. So just make sure you have that down and you have that understanding. Oh, what's going on? Why can I not switch? Hold on. Okay. So to access a specific character in a string, you want to use these brackets. So regardless if you're taking the AP exam or not, this is a true statement. You want to use these brackets in order to access a specific character. Let's go ahead and see how that would work. So to get one character, you would put the index number inside of the brackets. So you always do the string name, bracket, and then index number to get a specific character. So when I say print string 0, the very first example right here, what would print? Capital H, very good, because this is the 0th character of our string. Just so you guys weren't aware, this string right here, hi, how are you, is the same thing as this one right here. So you could just look to the one below for reference. So string 0 in brackets just means the 0th character, which is H. So we will see capital H. Ooh. We will see capital H print out. What about this one right here? Print string 1. What would print here? I, very good. I would print out because that is the first character. What about if I did print string 7? What would print out? Yes, it would print out a space because it is there's literally a space there. So though you won't see it, there's technically a space, like, but you won't see the quotation marks. You'll just see like an empty space. What about string 15? If we try to print out string 15, what would print there? Very good, a question mark. That is what's going to print. So question mark. And then finally, what about string 16? This one's a little bit of a trickier one. So there's no such thing as 16, right? This will give us an error. Once you go beyond the scope of what you have for your string, if you have an index error, you will just get an error. So you will get like a physical error for when everything prints out. So let's go ahead and just try this specific example and see if we do get the same exact thing. Capital H, lowercase I, a space, question mark, and then an error. Oh, I don't know why this is doing this to me. Give me 1 second. I'm getting another headache from my computer. But we're almost out of time, so this is probably the last thing I'm going to cover with you guys, and then we'll finish up our discussion of strings next time. All right, here we go. I'm gonna go ahead and comment this stuff out. And so let's see, the string that we were dealing with was hi, exclamation mark, how are you? And we wanted to first off print string 0. And I'm just gonna copy and paste this because we were trying different, trying to print different things. We tried print string 0, we tried print string 1, print string 7, print string 15, and print string 16. We tried all of these. So when we try to run it after saving it, we can see exactly what prints. We see that capital H print for this one, the lowercase I print for this one, we have a space that prints for this one. And like you can tell that it is a space because there's just frankly nothing else there. We have a question mark printout for this one, and then you can see here we get an error specifically because of this line print string 16 because the index is out of range. There's no character that exists at the index 16. So we got an error, which is exactly what we predicted from our PowerPoint slide. So I really want to emphasize again, for pretty much every single coding language out there in the world, you will use 0 to start your indices. For AP Computer Science Principles, for some unknown reason, you're going to start at 1. But we will hammer that idea into your head more towards 2021. For now, just remember it starts at 0. That way you could do programming assignments and also do the homework assignments. But after we finish all of the Python stuff, we will transition into doing specifically AP Computer Science Principles concepts, and that will be where you have to kind of juggle both of them. But also just remember for the AP test, you need to start it off at 1.